So part 2 of Module 5 is on exponential growth. And so with exponential growth, remember that your growth changes by either a percentage or by multiplying by the same number. So whenever you see a percent sign, you know it's an exponential growth, or if it says like it's doubling or tripling or something like that, you also know it's exponential growth. Again, there's a recursive formula, and there is an explicit. And again, when we look at it, our n and our p sub n are variables, and our p sub 0 and r are going to be numbers. And the same thing over here for recursive. These are going to stay p sub n and p sub n minus 1, and then we're going to have a change. So this r is called our growth rate, and we're always going to change our percent to a decimal. So we're going to write our decimal as, or write our percent as a decimal. And same thing with explicit. P sub 0 is our initial amount, and r again is our growth rate. And what we want to remember is that r is the growth rate, but when we talk about the 1 plus r, so the whole chunk that's in parentheses, that's either called our growth multiplier or our common ratio. And I've seen that on exams where they ask you to find the growth rate and write it as a percentage, and also to find the growth multiplier or the common ratio. So make sure you know the difference between the two. One is just talking about just the specific R value, and the other one is talking about the whole entire thing that's in parentheses. So we're just going to use those formulas, and the first one we're going to use, or the first problem that we're going to do, is using the recursive. Sorry about that. So as we look, this is our P sub 0, starts with 1,000 fish, and it's increasing by 10%. So our R is equal to 0.1. All right, so then P sub 0 is given. So P sub 0 is our 1,000 fish, and so we're just going to put it in. And then if I was going to find P sub 1, the idea is that if I'm using my function up above as a recursive, then my equation would be, okay, well, P sub 1 then is going to equal P sub 0 times 1 plus my rate, which is 0.1. And so we know that our P sub 0 is 1,000, which I should have put in there. And then we're just going to put it in our calculator. So as we look at that, all right, so we're going to just put in, so we're just going to put in our 1,000. So our P sub 0, our P sub 0, and then times 1 plus our interest rate, or our rate, not interest rate, 0.1, and we're just going to get our answer, which is 1,100. So this is going to give us P sub 1 equals 1,100. And then in order to find P sub 2, we would have to say, oh, I need to know the P sub 1 number, and then I would need to multiply it by 1 plus 0.1. And I could continue on doing that. So I'm going to take 1,100, and I'm going to times it by 1 plus 0.1, and we would get 1,210. And we could keep doing that all the way through. But what's easier is if I wrote that as a explicit equation, then that's going to make my life a little bit easier. So if I was going to use an explicit, I might say, okay, my equation is going to be P sub n is equal to P sub 0, your initial amount, and then it's going to be 1 plus your rate, which is 0.1, all raised to the nth power. And this nth power is this number right here that I could put in. So instead of me having to figure out the number that happens before, I could figure out any of them. So if I wanted to know 5 right from the beginning, I could say 1,000, and then it's 1 plus 0.1, and then I can raise it to the 5th power. And I don't have to know what happens in 3 and 4 in order to get it. So I know that this is going to be 1610.51 because I can just put it right in. And normally, if we're talking about fish, I would probably round this to 1611, but either way. But the idea is that I don't have to know what happens previous if I write my explicit equation right from the beginning. I can figure out whatever number that I want, and that's why the explicit is nicer. So when I look at example 4, it's kind of the same thing. It talks about the population in Olympia, Washington, and it says it's growing at approximately 3%. So this is our R value. If I change it to a decimal, this is 0.03. The population in 2008 is your initial population. And it says if this growth continues, what will the population of Olympia be in 2020? So it's asking you for the population, which is going to be P sub n or P sub 12, because in 2020, that's going to be 12 years after 2008. So this makes n be 12. And you want to be really careful that you pay attention. Sometimes what happens is you guys are like so anxious to get into the solving part that you don't read the question as careful. And think that the year is 2020, the n value is 2020, but that's really a year. And so they're just saying, how far is it from 2008 to 2020? And that's my n value would be 12. So remember our equation then is P sub n equals P sub 0, 1 plus r raised to the nth power. So when I plug in my values, I'm looking for P sub 12. P sub 0 is 245,000. And we're doing 1 plus our rate, and we're raising it to the 12th power. And so we're just going to put it in our calculator exactly like that. So if I scoot our calculator to the other side, maybe not. I guess it's not going to let us do that. Or maybe it will. All right, so if we scoot it over to here and we put it in, we're going to go 245,000. And we're going to go 1 plus 0.03, close our parentheses, and then raise it to the 12th power. And when we do that, then that tells us that our population is going to be 349,311. And because we're talking about population, I would probably leave it like that as a whole number. I don't know what your computer is going to like, if it's going to be tricky about it. But normally, if we're talking about people, we don't do partial people. Example 5 is about a friend that's using an equation. So they're giving us an explicit equation, and they're saying from that explicit equation, it helps you predict what the annual tuition is going to be. And so it says, here's your formula, and what does the equation tell us? And so we're going to pick out the important pieces. So this 4,600 is meaning that you have $4,600 is the tuition in 2010. Whoops, that does not say 2010. All right, and then this 0.072, remember this is 1 plus r raised to the n. So 1 is there. So that 0.072 is our rate of increase. So when I move this over 2 places, that tells us that our r is 7.2%. And so this is how much is increasing each year. How much the tuition increases each year. And so sometimes they just give you an equation and ask you what the pieces mean. The next thing that we're going to talk about or review really quick is how to solve exponential equations. And so hopefully this is more a review than you're learning this, but the idea when we're using or we have a power is that we want to get the power part, the variable raised to the power, isolated. So I'm going to divide both sides by 294. And so I get x squared is equal to 49 over 294. And then I want to take the square root. So I take the square root, and it's going to give me an approximate value. And when we're using this in our problems, we want to make sure we leave the decimal in as, don't round until the very end. When you're using it, like when we're doing this problem, I would just round it to a place value. We're going to round it to the hundredths place. So the 8's going to bump that 1 up, so that we're going to say this is 0.41. All right, or if it's the 5th power, then we get rid of it by taking the 5th root. And the way we do that on our calculator is we're going to put the 5 in first, then you push math, and then you go down to number 5, and then we're putting in the 32. That's one option. So that gives us m is equal to 2. Another option that you could do is we could raise it to 1/5 power, and that would also give us 2. And if I was to put that in my calculator, I would say I'm going to do 32 raised to, and then in parentheses 1 divided by 5. And notice how that I'm still going to get 2. So that's just another option. You don't need to do it that way. It's just whatever's easier for you. When I look at letter C, our first step is to get the a to the 3rd isolated. So we divide both sides by 7. And this is going to give me 125. And then we're trying to get the cubed root to go away. So we're going to either raise it to the 1/3 power or take the cubed root. And when I take the cubed root, again, you can use your calculator if you want to. If you know that it's going to be 5, you can do that as well. But again, if I want to do cubed root, I can either push the 3 first and then go to math and then down to number 5 and put in 25, or not 25, 125. 125. Oh, didn't do 125. Try that one more time. 3, math, 5, 125. Okay. So we can get 5, or we can push just math, and this one actually has a cubed root, so you could go 4, push 125. Or we can put in 125 and raise it to the 1/3 power. And all of those, notice, give us 5. So different options, whatever's easier for you. All right, so we're going to use that in order to solve an equation. And so as I look at example 6, it says, suppose a population of honeybees in Ephraim, Utah has an initial population of 6,600. So this is our P sub 0. 10 years later, the population reaches 15,000. So this is n is equal to 10. And this is going to be our P sub 10. And it says use an explicit exponential model to find the common ratio, which is the 1 plus r, and use it to find the growth rate. So remember that our general form is P sub n is equal to P sub 0, 1 plus r to the n. And so we're going to use this equation, plug in what we know, and solve for r, or 1 plus r in this problem. So P sub n is 15,000. P sub 0 is 6,600. 1 plus r is going to stay 1 plus r, and our n value is 10. So our first step is to get rid of or isolate the part that's being raised to a power. So we're going to divide both sides by 6,600. And we're going to get a decimal, which is fine. So this is 1 plus r to the 10th power. And over here, we're going to go 15,000 divided by 6,600. And so we get this decimal of 2.27 repeating. So this is 2.27 repeating. And we want to make sure that we keep that whole number. I know that it's a little bit of a pain, but we want to keep it where it's at. So we're going to raise it to we're going to take the 10th root of both sides. And you guys can do this a couple different ways. You can either raise it to the 1/10 power, or you can take the 10th power, and it doesn't matter. And so what that does is it's going to give us 1 plus r is equal to whatever we get. And so as we look at our calculator, we want to use the value that we have here. So we either can say we're going to raise it, so it takes the number, and we're going to raise it to the 1/10 power. That's one option. Okay, and so we get 1 point, and we're going to round it to the thousandths place. So tenths, hundredths, thousandths. So the second 5 is going to bring our first 5 up to a 6. So this is 1.086, and that's our value that's going to go here. All right, another option is we could have, we also could have said 10 and pushed math and then gone down to number 5 and put our answer in. All right, and then we're still going to get the same number. So it's kind of up to you. And then the next part, so the B part says, well, now I just want to know the R. And so in order to find the R, we're going to get rid of this 1. So we're going to subtract 1 from both sides. And that's going to give us R is equal to 0.086. We're going to want to write it as a percentage, so we move it over 2 places, and this is going to be 8.6%. All right, and so that's going to give us what we need there. All right, so then the next thing that we want to review is logarithms. You guys learned logarithms in secondary 3, and the main idea here, well, this should say something. This should look a little bit different. The main rule here is that we're going to have the log of, well, an easy way to do that is take the log of each side. So this should be the log of A on both sides. And so I think that there's just one extra log there. So as we look at this to solve, remember the idea is we're trying to get rid of the base 3. And so what we do is we do log base 3 on both sides. And then there's a base formula that you guys used, and you took log of the big number divided by log of that little number, that little base number. And so we just plug that into our calculator. And so we're going to do log is next to 7. So you're going to go log of 243, close your parentheses, divided by log of 3. I can't remember. And we get 5. Okay. Now, another way to look at that would have been 3 to what power is 243, and it comes out, this one comes out nice, and maybe we know that. But when I look at example B, it's not quite so nice. So we're going to isolate the part that's raised to the x power. So we're going to divide both sides by 2. So we're going to get 24 is equal to 5 to the x power. And then we want to get rid of the base 5. So I go log base 5, log base 5, and this goes away. And so in our calculator, we're going to go x is equal to log base 24 divided by log base 5. And so we're going to go log 24, close our parentheses, and that's really important that you close your parentheses, divided by log of 5, close your parentheses. And so we're going to get 1.97. Remember, as we're using this method to solve, we don't ever want to round until our very last step. So as we look at example 7, it says in 2003, median home prices in Midvale, Utah have been growing exponentially at roughly 4.7%. So this is our R value. So our R value is going to be 0.047. It says if you purchase a house in Midvale for $164,000 in 2004, so this is our P sub 0. It says in what year would the home be worth $232,000? So this is P sub n. And what we're looking for is that, well, we're kind of looking for what n is. So as we look at our equation, it's P sub n is equal to P sub 0, 1 plus R raised to the nth power. So P sub n is 232,000. P sub 0 is 164,000. Our rate is 0.047. And what we're looking for is n. How many years is it going to take to reach that amount? And then what we're going to do is we're going to figure out in what year that happens. So n tells me how many years it's going to take. but then we're going to have an extra step. So our first step then is to divide both sides by 164,000, which is going to come out as a decimal. And so we're going to get, and I'm going to add these two together. So this is going to be 1.047 n, and this is going to give us, let's see, 232. We can put the zeros in if you want to, divided by 164. The zeros kind of cancel each other out, so we don't necessarily need them. And so we get, what did I do? 232 divided by 164. And so we, dang it, 232, promise, divided by 164. Okay, so that gives us 1.4146. It gives us all that junk, okay? So I don't want to write all that junk down, so I'm just going to be 1.41 ... okay? So what I want to do is get rid of this base of 1.047. So what I do is I'm going to take log base 1.047, and I'm going to do that same thing over here, 1.047. And so that makes this go away. And then when I go to put that in my calculator, I'm just going to do log of that 1.41 ... and I'm going to divide it by log of 1.047. And the easiest way to do that in your calculator is we're just going to go log, and we want to put that answer that we just had. So we're going to go second, -1, that puts our answer in, close your decimal, or close your parenthesis, divide by log, and then we're going to put our value in, which was 1.047. Yep. So we're going to do log of 1.047. Whoops, that was not a 7. All right, close our parentheses. And so it tells us that it's 7.55. So this gives us 7.55. Now, well, and a whole bunch of other crap. So it wants us to round to the nearest year. Okay, so this is going to be 8 years if we round to a whole number. And then the house was bought in 2004. So if I take 2004 and I add 8 years to it, that means that it is worth, or was worth, $232,000 in the year 2012. And so you just want to be careful as you read your question. Does it ask you in what year, or does it ask you how many years? All right, because it's going to depend on that. Example 8, as we look through it, kind of the same thing. It says the small town is currently 13,000, so that's P sub 0. It's growing exponentially at 1.7, so R is equal to 0.017. And our population reaches 26,000, so that's P sub n. And we're looking how many years until the population reaches that. So we're just going to do the basic same thing we did up above, but our answer would be whatever we get. So our equation again is P sub n is equal to P sub 0, 1 plus R raised to the n. And then we put everything in. So this is 26,000. P sub 0 is 13,000. This is 1 plus 0.017. And n is what we're looking for. And so our first step is we're going to divide by 13,000. And this one's a nice one because it's going to give us a nice clean number here. So this is 2. And this is going to give us 1.017 raised to the nth power. And again, we want to get rid of that. And so the easiest way to get rid of it is do a log. So we're going to do log of 1.017, log of 1.017. And so this is going to give us n is equal to, and we're just going to put that in our calculator. So we're going to go log of 2, close your parentheses, divided by log of 1.017, close your parentheses. And so now we're rounding to the nearest year because it tells us that. So 41.1 would round just to 41 years. So it's saying it would take 41 years for your population in this small town to double. All right, so example 9, I think there's a problem like this in your exercises or quiz, and it just talks about inflation. And the difference between this and what we just did is that inflation decreases the value of money instead of increases it. And so our equation will stay the same, except for instead of adding, we're going to be subtracting our rate because it's decreasing. So in this case, we want to know how much $100 would be worth. So this is what we're starting with in 20 years. So N is going to be 20 if it decreases by 5% each year. So 1 minus 0.05, we're going to put in 20 right here, which I guess that would make this, instead of P sub N, we should write P sub 20. So P sub 20 is going to equal, and again, we're just putting it in. So it's 100, which is our P sub 0. Instead of adding, it's subtracting 5. And we're going to put in for 20 years. And so that means that $100 is going to be worth $35. And remember, we're talking about money, so we're rounding to the hundredths place. So it will be $35.85. All right, and so that's how much your $100 is worth. So there is a written assignment for Module 5, and I think it's changed a little bit. I think they might even give you the equation now. I was going to look that up before I talked about this, but notice that there's two options, an option A and an option B, and what they're trying to get you to do is figure out when is one option better than the other for Lucy, like which, like it'll say if it's 6 bushels, which option should she take? If she picks 12 bushels, which option should she take? And when you write the function, the key there is they want you to think about what happens in option B when it's 1 penny, 3 pennies, 9 pennies. How can you write an equation, an explicit equation, so that you can find out when one option is better than the other option, instead of just doing a T-chart? You can very well do a T-chart and answer all the questions here, but just kind of look at that. Make sure you do your written assignment for this one. I think it's worth 30 points, so it's kind of worth more than some of the other written assignments. The last thing we're going to talk about is logistic growth. Logistic growth it's always a recursive formula, and it basically is talking about where you have a population that's constrained. And constrained means like there's boundaries. So like it's in a lake or a pond that you can't get out of, or it's in a fenced sanctuary area, or it's in a petri dish. So you're doing like it's closed. So the environment has a carrying capacity. And that's the key to a logistic growth, is that it can only sustain or take care of so many before there's not enough room or not enough food or not enough space. I guess space and room would be the same thing. So anyway, that's kind of what it means. So when we look at logistic growth model, this is the equation, which is always given to you. There's not an explicit formula. It's only recursive. And P sub N is still the same, or P sub N minus 1 is still the same thing. So this is the previous value. This is our rate as a percentage. We don't need to add 1 or nothing like that. This is still our previous value. This is the K stands for our carrying capacity. And P sub N minus 1, again, is your previous value. And so with this, couple things, logistic growth, the growth rate is not constant. So it talks about how during the first few years, the population increases really fast. And then as the population increases or approaches the carrying capacity, the growth is going to slow down. And sometimes it's going to go above the carrying capacity, and then the next time it's going to go below. And it's going to kind of like go up and down close to that carrying capacity until it eventually is steady. So what that means is that if this is your carrying capacity, you're starting down here and it's going to grow fairly quickly, not necessarily linearly, but it's going to grow. And then it's going to kind of go above and below until it eventually levels out, where it stays pretty close to that carrying capacity. So the main idea here is that we can figure out how much, but again, we have to keep track of the previous one. So in this case, P sub 0 is 50. Your growth rate is 60%, so 0.6. And we're just going to figure it out. When it talks about absent constraints, that means like there wasn't a wildfire that killed a whole bunch of deer that normally wouldn't happen, or there wasn't, like a really bad snowstorm that kills them off. So absent constraints means like in the perfect world, basically. So P sub 0 is 50. So to find P sub 1, we take P sub 0, and then we're just using this formula up here. So we're going to go plus R. So our R is 0.6, and then it's 1 minus your P sub 0 divided by your carrying capacity, which was our 400. And then you're going to times that by our P sub 0. So in our calculator, we just do that. So we're going to go 50 plus 0.6 parentheses 1 minus 50 divided by 400. Close our parentheses and then times it by 50. So we get 76.25. So now to find P sub 2, everywhere there's a 50, so here, here, and here, we're going to put now 76.25. So other than that, everything else stays the same. So this is still going to be plus 0.6. This is still 1 minus 400, but this is going to change to 76.25, and this is going to change to 76.25. So in our calculator, same thing. We're going to go 76.25 plus 0.6, 1 minus 76.25, 25, divided by 400, close our parentheses, and then times it by 76.25. And so we're going to get 113.28. So 113.28. Now, because we're talking about deer, I think the computer will take 76 and 113, which is fine. But when you go to find the next number in the sequence, you have to use the decimal answer. So even though here you might say it's 76 because you're talking about deer, when you go to find the next value in the sequence, you have to do 76.25. So just giving you that heads up, because if you round it to and then use that number for the next one, it gives you the wrong answer. Example 11 is the same. This is like 1,000 lizards, so this is P sub 0. Oh, no, it's not. Island can support a population of 1,000, so this is K. The population is 600, so this is P sub 0. And this time your rate is going to be 1.5, because when you move it over 2, and then it wants you to find the population in 3 years. In order to do this, you have to find P sub 0, P sub 1, P sub 2, and then find P sub 3. So P sub 0 is easy because that's 600. But then I would have to do this same process 3 times in order to get to P sub 3. And again, your equation would just be P sub 1 is equal to 600. 600 plus 1.5, and then it's 1 minus 600 over 1,000, and then times by 600. And what's going to happen is that you're going to get a value that goes above and below. So we're going to go 600, and then this is going to, oh, dang it, delete. That can't quite clear. All right, try again. 600, and then it's going to be plus 1.5, parentheses, 1 minus, and this will be 600 over 1,000. And then we're going to times it by 600. And so we're going to get 960. So this is 960. And now everywhere the 600 was, we're going to put in 960. So now instead of 600, so here here, and here, we're now going to put in 960. So in our calculator, we're going to go 960 plus 1.5 parentheses 1 minus 960 divided by 1,000, close our parentheses, and times it by 960. So now we get 1017.6. And notice how that is above the carrying capacity. So it was below, and then it got close to it. Now it's above. And now when I go to find P sub 3, everywhere the 600 or the 960 was, now I'm going to be putting in into that spot, I'm going to be putting in the 1017.6. So everywhere the 600 is, we're putting in 1017.6. So we're going to go 1017.6 plus 1.5 parentheses 1 minus 1017.6 divided by 1,000. And then we're going to times it by 1017.6. And you'll notice that this is going to go back down. So now we're back down to 990.74. And so what's going to happen if I do the next one is going to go back up. And it's going to kind of just oscillate around that carrying capacity. So the next thing talks about the growth rate. And the growth rate, remember, is adding or subtracting the same number. Exponential is if you have a percent sign or you're multiplying by a number. And logistic is not constant. This one's going to be looking a little bit different. So if it's adding or subtracting, then your line, you're going to either have a graph where your line goes up or a graph where a straight line where your graph goes down. Or if it's exponential, it's going to be a curve going up that grows slowly, or it's going to be a curve going down. When it's logistic, that's where we have that carrying capacity, and it's going to grow, and then it's going to kind of like level off eventually. And that's what your function's going to look like. All right, so that's everything for Module 5. Again, remember there's a discussion, there's exercises, a quiz, and a written assignment. Let me know if you need any help.